Your last set of homework is going to have problems that are going to look a little bit different, and they are incorporating what we were doing in our lab with our ammeters and voltmeters, right? Or our current sensors, which is the same as an ammeter, and our volt sensor, which is the voltmeter. So what happens is if you had a picture like this, right, of your circuit, we might ask, like, what's the current through the 6 ohm resistor? Well, remember that's in series with the battery. So now in your homework, instead, you're going to see an ammeter placed before or after that 6 ohm resistor. And that essentially is the same thing. It's asking you what is the current through that 6 ohm resistor, because the ammeter measures the current at that location. So if you were doing that type of problem, you're going to start out the same way. It might not ask you, but you are going to find out the total resistance. So the 3 ohm and the 6 ohm are parallel to each other. So 1 over 3 plus 1 over 6. Right, that's going to give us 3 over 6. Taking the inverse of 3 over 6, you get 6 over 3, which gives us a resistance of 2 ohms. So if you have now a circuit, right, that has a 6 ohm, the equivalent path of our 2 ohms, using that simple circuit, we know that the total resistance is going to be 6 plus 2, or 8 ohms. So you always need to find that, and then after that, then you're going to start solving for what would be in these ammeters and voltmeters. Well, the first ammeter that we placed in here, right, we'll call this ammeter 1. So ammeter 1, the reading, because it's in series with the battery, would have the same current that comes out of the battery. So finding the current that comes out of the battery, right, using Ohm's law, I equals V divided by R. So if the voltage of your whole entire circuit is 24 and your resistance of your whole circuit is 8, right, 24 divided by 8 is 3 amps, which means 3 amps is going to come out of your circuit, and so 3 amps would go through that ammeter 1. If we placed other ammeters at any of these locations, right, because they are in series with the battery, then all of those would also equal our 3 amps, right? So if we said ammeter 2 and ammeter 3, so ammeter 2 and ammeter 3, because they're in series, would have the same thing. Now the voltmeter, remember that when you were checking the voltage, you would put that between 2 points. So let's say if I put it here, right, what would that voltmeter do? If we call this voltmeter 1, if we call this voltmeter 1, then that voltmeter, right, it's going to measure the difference in voltage from this location to this location. Well, the only thing between that is the battery, so voltmeter 1 would read 24 volts, right? It would read the battery. If you had a voltmeter that was on that 6 ohm resistor, right, looking from in between here and here is a 6 ohm resistor, so what's the voltage of, let's say we'll call this 2, what is that second voltmeter going to measure? Right, well, voltage, it should be a 2. Voltage is I times R. Well, the current going through, we've already figured out, is 3 amps. It has a resistance of 6, so there would be a difference of 18 volts. So hopefully you're seeing the math is exactly the same. It's just a different way of asking the same question. You know, they might ask, okay, well, what is our ammeter 4 going to read? Well, that's just the current that's going down that branch. So how do we find the current that goes down that branch? Right, we could use the ratio. We can take the current that comes out of the battery of 3, we take the resistance of the other pathway, 6, we put it over the resistance of both pathways, so 9. So what is that? 2/3 of the current goes through that ammeter. So what would that be? 2 amps. right? So 2 amps goes through ammeter 4. If you attached another one, if you put it here, or if you put it here, or if you put it here, right? All of these 4 that I just added, all of those would measure exactly the same because it's all in this pathway that has the same current. So if I wanted to know the amps in any of those amp meters, I would do the same idea that I was doing here, right? I would take, to find that current, I would be 3 over the other pathway, right? Had a resistance of 3, the total of 9. So 1/3 of the current goes down that pathway, so 1 amp. If you were to go through and attach a voltmeter, right, let me clear out some of these pictures here. If we were to go and attach a voltmeter at any of these locations, right, if we were to stick it here, that's just asking you what's the change in voltage down that pathway. So again, I'm going to call this voltmeter 4. So what happens with voltmeter 4, right? It has a current of 2 amps. We figured that out, right? Current of 2 amps. And it has a resistance of 3. So there is going to be a change of 6 volts down that pathway. And the last one, right, if you put a voltmeter here, we're going to call that voltmeter 5, right? How would we find that voltage? Well, we know that 1 amp goes down that pathway. It has a resistance of 6, so 6 volts. And that makes sense because parallel pathways are supposed to have the exact same resistance. So you see, all the math is the same, it's just a different way of asking the same question.